a type of geometric example you could be given is also being given two different terms in the sequence and needing to find what the pattern is. So this one says the third and the eighth terms of a geometric sequence are -2 and 64 respectively. So the first one is to find the common ratio. So we know that the third term, so a sub 3, is -2, and we know the eighth term, so a sub 8, is 64. So just like before, I'm going to choose to write a system of equations and use substitution. So I know my explicit formula for geometric is an equals a1, struggles, equals a1 times r to the n minus 1. So I'm going to plug in what I know into that. So for this equation, I know an is -2. That's my next term. Then first term, still don't know the common ratio. And then an is which term I'm on, which is the third term, -1. So I'm going to choose to evaluate this to get a1 by itself. So we've got -2 equals a1, a1 r raised to the power of 2. So to get a1 by itself, we can divide. So we've got -2 divided by r squared equals a1. For the second equation, I can plug it in and I'll get 64 equals a1 r to the 8 minus 1. Then just like before, I can use substitution. So since a1 equals this, I can substitute it in for a1 here. So it'll look like 64 equals -2 over r squared multiplied by r to the 7th. Hopefully you know from learning exponents that if we've got r7 over r2, we can subtract those exponents. So this is going to leave and this will become r5. So we now have 64 equals -2r to the 5th power. If we divide by -2, we get -32 equals r squared, r to the 5th, sorry. And then if you take the 5th root of both of these, the 5th root of -32 is -2. So my common ratio is -2. If we then wanted to find the common, or the first term in the sequence, we could plug -2 back into here, where we've isolated the first term. So we have a1 equals -2 divided by the common ratio, so -2 squared. So -2 over 4. So -1/2 is our starting term. Finally, we can put it all together and write our explicit formula. So our explicit formula is going to look like an equals, then our first term is the -1/2, times our r, which is -2, raised to the n minus 1. And this formula can be used to find any term in the sequence.